So in this video, we're just going to go through all of the ratio and proportion topics needed for grade 6. Okay, so here I've been given a ratio and I'm asked to write it in its simplest form. Now, when it's in its simplest form, it means it wants both parts of the ratio to be integers and to be simplified as much as possible. So I've got 4.8 to 1.2. Both of these numbers are decimals. So what I can do is I can times by 10 in order to turn them into whole numbers. So that would become 48 to 12. So now they're both integers, but I want to write it in its simplest form. So in order to simplify ratio, all you do is you divide both sides by the same number. So let's divide by 2. If I divide both sides by 2, I'd end up with 24 to 6. I could divide by 2 again, so that would be 12 to 3. And once I get to 12 to 3, what can I divide both sides by? Well, something that fits into both would be 3. So if I divide both sides by 3, I end up with the ratio 4 to 1. Okay, so in its simplest form means they both have to be integers, whole numbers, and also simplified fully. Now in the next question, I'm told that Dimitri finds that the ratio of his friends that walk to school versus drive to school is 8 to 16. And I want to write this in the ratio 1 to n. Okay, so this isn't in its simplest form, it's 1 to n, which means you think, okay, how do I get from 16 to n? From 8 to 1? Well, I divide by 8. So I'm going to have to do exactly the same thing to the other side. So 16 divided by 8 is 2. So then you're left with the ratio 1 to 2. Okay, so some people are like, what does this even mean? It literally just means you want one part of your ratio to be 1 and the second part, it could be a decimal, it doesn't matter as long as you just write the first part in the ratio of 1. Okay, so sharing in a given ratio, Vardhi and Rayan share £360 in the ratio 3 to 2. How much does Rayan get? So if we just try and visualize it, Vardhi gets 3 parts for every 2 parts that Rayan gets. So what we can do is add the parts together. In total, there are 5 parts. So we can do 360 divided by 5. So if you need to, you can use the bus stop method. So 5s into 3 goes 0, 5s into 36 goes 7, remainder 1, and 5s into 10 are 2. So I know that each part is worth 72. And I know that Rayan gets 2 of the parts. So I'm just going to do 72 times 2, which is 144. For the next question, I'm told that Kasim and Abdul share some money in the ratio 5 to 2. Now this question's a little bit trickier because you're not dividing a whole into parts. You are using some knowledge that you've been given. So you know that Kasim gets 1, 2, 3, 4, 5 parts and Abdul gets 2 parts. And I know that everything that Kasim has got is equal to £350. Now Kasim gets 5 parts. So if I do 350 divided by 5, that will tell me what one part is worth. So 5s into 3 I can't do, 5s into 35 are 7, and 5s into 0 are 0. So I know that each part is equal to 70. Go away, Siri. And therefore, how much does Abdul receive? Well, he receives 2 parts, so therefore he receives 140. So just be very wary. Sometimes you're not going to be given the whole, you're going to be given the value of the parts. So use that to figure out what one part is and then multiply. Okay, so some more ratio with parts. Jasmine and Valentina share some money in the ratio 3 to 5. Valentina receives £100 more than Jasmine. How much money do they have between them? So once again, let's think about it. So Jasmine gets 3 parts for every 5 parts that Valentina receives. And Valentina receives £100 more in total than Jasmine does. So Jasmine has 3 parts and Valentina has 3 parts. They're going to be equal. And I know that the remainder, which is 2 parts, is worth £100. So if I split that, I know that 2 parts must equal £100 because that's how much more Valentina has than Jasmine. So each part must be worth £50. So if I know that each part is £50, I could either colour it in and make it look pretty like this, Or you could just do the really quick, efficient way. You know there are 8 parts in total, so you do 8 times 50, which is going to be 400. Similarly, Adam cuts his rectangular birthday cake into 3 pieces, into the ratio 2 to 3 to 5. So 1, 2 parts, 1, 2, 3 parts, and then 1, 2, 3, 4, 5. Okay, so in total, 2 plus 3 plus 5 is 10 parts. Now, the piece of information I've been given, so have I drawn enough parts? That's 1, 2, 3, 4, 5, missed one. So the largest piece is 18 centimeters longer than the smallest piece. Okay, so let's have a think about this. The largest piece is worth 5 parts, and it's 18 centimeters longer than the smallest piece. So what's the difference in parts? Well, that's 3 parts. Oh, I've done this wrong. Sorry, that should just be 2 parts. And that's where I went wrong. Okay, so I know that 2 parts is what is equal to this. So therefore, 3 parts must be equal to 18 centimeters. The difference between 2 parts and 5 parts is 3 parts. So if I know that 3 parts is equal to 18 centimeters, I can figure out that 1 part is 18 divided by 3, which is 6 centimeters. So I know that each little part is 6 centimeters, and I need to work out the length of the second piece of cake. Now, the second piece of cake is worth 3 parts, as I was told here. So 3 parts is going to be 3 times 6, which is 18 centimeters. And that's how I do a question like that. So now I'm combining 3-part ratios. Okay, so I know that x to y is in the ratio 2 to 3. And I also know that y to z is in the ratio 4 to 7. So when you've got 3-part ratios, you can set them up as x to y to z, and then one of them is going to be common to both parts of the ratio. So I know that y is common to both. So what I want to do is change it into equivalent ratios so that I have a common multiple. So the lowest common multiple of 3 and 4 is 12. So what I want to do is multiply this ratio by 4 and this by 3, and then both of my y parts would be 12. So 2 times 4 is 8, 3 times 4 is 12, 4 times 3 is 12, and 7 times 3 is 21. So when I've turned the middle part into equivalent ratio, so technically it would have been 8 to 12 and then 12 to 21, but when you have a common part, you can just write them all together. So that's how I do that. The ratio x to y to z would be 8 to 12 to 21. And then it says express x as a fraction of the total of the 3 numbers x, y, and z. Well, if x is 8, x, y, and z, if I add them together, 8 plus 12 is 20, 20 plus 21 is 41. So I just write it as 8 over 41. It hasn't asked me to simplify, so I don't need to. So this one is slightly trickier. The key thing is when you're dealing with ratios, so if I had the ratio 2 to 3, okay, that's the ratio 2 to 3. And what I can do is I can actually set that up if I knew that the equivalent ratio was, let's say, 4 to 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so 4 to 6. What I can do is actually set it up as an equation, because 2/3 is equivalent to 4/6. Okay, so when you've got equivalent ratios, which is going to be signaled by an equal sign, you can turn the ratio into a fraction and compare them. So I know that a over b is 3/5 and b over c is 1/4. So there are a few ways I could do this. I could either write the ratio a to b is equal to 3 to 5, and therefore the ratio b over c, which is 1/4, so the ratio b to c is 1 to 4. So I could do that. So if we followed this strain, I know that a to b is 3 to 5 and b to c is 1 to 4. I turn it into equivalent ratios by finding the lowest common multiple, which would be 5. So that would become 15 oh, sorry, no, I'm not changing that one. So that remains as 3 to 5. It's just this equation, this ratio I'm multiplying to 20. Okay, so I could leave it like that, 3 to 5 to 20. And actually, let's just leave it at that. There is another way where you could turn it into equations, but let's just, for the purpose of this, the key message is you can turn, if they are equivalent ratios, whatever the ratio is, like it says here, A to B is equal to A over B. Okay, so a ratio question in context. Zara, Brianna and Isabella buy some sweets from the shop. They share them out in the ratio 4 to 8. So 1, 2, 3, 4 parts to 8 parts to 13 parts. Okay, Isabella, so let's just write their names. So Zara, Brianna and Isabella. Isabella has 25 more sweets than Brianna. So how many parts does Brianna have? 8. So this is equivalent. Okay. So how many more does Isabella have? Well, she has 1, 2, 3, 4, 5 parts more. So therefore 5 parts must equal 25 sweets. So if I know that 5 parts is equal to 25 sweets, I know that 1 part must equal 5 sweets. I just divide by 5. Quick way is just to think, okay, 8 to 13, what's the difference between 8 and 13? 5. So therefore 5 parts must equal 25 parts, but it's also nice to visualize. Now, Isabella has more sweets than Zara. How many more? Okay, so I know that 1 part is 5 sweets. I know that Isabella has 13 parts. So 13 times 5 is going to give me 65, because 10 times 5 is 50. 3 times 5 is 15. So Isabella has, oh, let's write it somewhere. Isabella has 65 sweets in total. And then Zara has, well, Zara has 4 parts. So I do 4 times 5, which is 20. So Zara has 20 sweets. And the question says, how many more sweets does Isabella have than Zara? 65 take 20 is 40 sweets. So you just say, Isabella has 40 sweets more than Zara. Okay, so here's an exchange rate question, and exchange rates are used all the time in the real world, so it's helpful to know them. So Nikan wants to buy a new phone. The phone costs £550 in the UK and $650 in America. The exchange rate as £1 is $1.30. And where should he buy his phone if he wants to buy it cheapest? So I can either convert the dollars into pounds or the pounds into dollars. In this case, it might be easier, because this is non-calculator, to turn the pounds into dollars. So I know £1 is equal to $1.30. I want to figure out what £550 are. So what have I done to turn 1 into 550? I've times by 550. So I need to do the same over here. Now, non-calculator paper, I just like doing the lattice method. You can do whatever method you like the most. But you're going to need to do, well, you could do 1.3 times 550, I suppose, or you could just do 130 times 550. I'm just going to do that to work out what it is in pence. So with the lattice method, you just divide each section into 2, and then your tens go in the top little diagonal, and the ones go over here. So 0 times 5 is 0, 0. 0 times anything is 0, so both of those columns are going to be 0. 3 times 5 is 15, 3 times 5 is 15, and 3 times 0 is 0. 1 times 5 is 5, 1 times 5 is 5, and 1 times 0 is 0. And once you've filled it out, you just go along your diagonals. So this diagonal adds to 0, this diagonal adds to 0, this diagonal adds to 5, this diagonal, 5 plus 5 is 10 plus 1 is 11, so you carry the 1 into the next column, and 5 plus 1 is 6. So I know that £550 is 61,500 cents. So turn that into dollars, divide by 100. £550 is equal to, I don't know why I did it in a ratio, $615. So therefore, where is the phone cheaper? Well, it's $615 in the UK and $650 in America. Therefore, he should buy it in the UK. If it was a calculator paper, you could also have divided 650 by 1.3, but as it's a non-calculator, I just went for the easiest option. Okay, so direct proportion we use all of the time in real life. So Suman wants to make some muffins for her classmates. The ingredients needed to make 20 muffins are this. She has 150 grams of butter and wants to make muffins for her class of 30. How much of each other ingredient does she need? Well, I know that to make 20, these are the ingredients. So what I could do is to work out how much you need for 10. So divide everything by 2. So she'd need 100 grams of flour, 50 grams of butter, 37.5 grams of sugar, and 7.5 grams of chocolate chips. Now there's a few ways you could do this. To work out 30, what you could do is you could times each ingredient by 3, because 10 times 3 is 30, or you already know the ingredients needed for 20, so you could just add on the ingredients of 10. So in total, she'd need 300 grams of flour. Actually, I'm going to write that closer because that's not the end of the question. So for 30 muffins, she needs 300 grams of flour, 150 grams of butter, because I've added 150. I'm just adding. I could times by 3 as well. 75 plus 37.5. So let's just do this. So 0 plus 5 is 5. 5 plus 7 is 12. 7 plus 3 is 10. Plus 1 is 11. So that would be 112.5 grams of sugar. And then 22.5 grams of chocolate chips. The question is asking how much of each other ingredient does she need? Oh, I thought it asked how much more. Okay, well, how much of each ingredient does she need? She needs 300 grams of flour, this much of sugar, and this much of chocolate chips. Okay, so here we've got a best value for money kind of question. Now, all you need to do for a question like this is, I think I'm losing my voice, is find out the cost of one thing. So in this case, Isabella wants to buy some toilet roll. She can buy a pack of 24 for £4.80 or a pack of 10 for £2.50. Now, when you are old enough to be responsible for buying the toilet roll of your household, this is actually something you're probably going to want to actually do just to figure out what saves you the most money. So for pack 1, she can buy 24 rolls for £4.80. So if I turn that into pence, I can do 480 divided by 24 to figure out the cost of one toilet roll. And similarly, £2.50 is 250 pence, and divided by 10 gives me the cost of one. So let's start with the easiest one. Divide by 10, that's 25 pence for one toilet roll. And that's from pack 2. And for pack 1, what do I do? Well, it's non-calculator, so you can just turn it into equivalent fractions. So let's divide by 2 on both sides. So that would be 240 divided by 12, divide by 2 again, 120 over 6, divide by 2 again, 60 over 3. You can keep on dividing by 2, or 60 divided by 3, we know is 20p. So which one offers the best value for money? Pack A is the cheapest, 20p versus 25p. And just always compare the costs to show, and always show you're working. If you just say pack A, that you get no marks. Okay, so in this question, I am dealing with density. So the formula for density, and this is not a formula that you're given, but sometimes they do give it to you. Density is mass over volume. So I am told that liquid A has a density of 2 grams per centimetre cubed. I'm just skimming the question. I'm noticing that there are 3 liquids. So whenever you've been given a lot of information, you might just want to form yourself a two-way table so that you can collect it and you don't get lost. Okay, so we've got, why did it just delete? We've got density, mass, and volume, and then we've got liquid A, B, and C. So let's fill in the information I have. Liquid A has a density of 2 grams per centimetre cubed. I'm just trying to scan to see if I know any information about A. Nope. I know that 100 centimetres cubed of liquid A is mixed with some of liquid B to make liquid C. So let's say the volume is 100 centimetre cubed. Remember, just as a quick thing, because people always seem to get these confused, even though you know what volume is. So with density, okay, they've told you the density is 2 grams per centimetre cubed. So that tells you the units. So you know that mass is going to be in grams and that the volume is going to be in centimetres cubed. Okay, because density is mass over volume. This little line means over. Okay, liquid C has a mass of 400 grams and a density of 0.5 grams per centimetre cubed. Find the density of liquid B. Okay, so this is quite a extensive question for non-calculator, but let's go for it. So what information do I know? Well, I know 2 pieces of information about liquid C and about liquid A, so I can start there. So for liquid C, I know its density and its mass. So to work out volume, I can just rearrange the formula, and I know that volume is mass divided by density. So in this case, the volume of liquid C is going to be the mass, 400, divided by 0.5. Anything divided by 0.5 is the same as dividing by a half, and when you divide by a half, it's the same as timesing by 2. So that's just a nice non-calculator trick to just have. So therefore, the volume is going to be 800 centimetres cubed. Okay, now I need to work out the density of liquid B. So I need to work backwards. If I know, what do I need to know? I need to know the volume of liquid B. Well, if 100 centimetres cubed of liquid A is mixed with some of liquid B, then therefore this must be 700 centimetres cubed. Must be mixed with it. So the next piece of information I can work out is what the mass would be of liquid A. So how do I work out mass? Well, mass is density times by volume. So 2 times by 100 is 200 grams. So I know that the mass of liquid A must be 200 grams. And using that, I can figure out what the mass of liquid B must be. 400 take away 200 is 200 grams. Okay, so now I have the pieces of information that I need. How do I work out density? Density is mass, which is 200, over volume, which is 700. So it says give your answer to 3 significant figures. That would simplify. Divide by 10 would be 20 over 70. Divide by 10 again would be 2/7. So I can do 2 divided by 7. 7s, and I know I'm going to have 0, so let's just add them now. 7s into 2 go 0, put the decimal point, remainder 2. 7s into 20 go twice, remainder 6. 7s into 60 go 8, remainder 4. 7s into 40 go 5, remainder 5, and 7s into 50 go 7, remainder 1. So I know the density is 0.2857, and it says give it to 3 significant figures. So I circle this, look next door, it's 5 or more, so I add 1 more. So the density of liquid B is 0.286. Okay, so next I'm dealing with a pressure question. So pressure is force over area. In this question, they've given it to you. So sometimes they give it to you, sometimes they don't. So it's good to know them just in case. So I'm told that the cone has a height of 20 centimetres and a radius of 3. So that's 20 and that's 3. The volume of the cone is 60 pi. So how do you work out the volume of a cone? You don't actually need to know that necessarily, but the volume is going to be the area of the cross section. So that's going to be pi r squared times by the height divided by 3. So volume of a cone is a third of the, imagine it's a rectangle. So if we imagined it's a rectangle, you work out the area of the base, or a cylinder rather. You work out the area of the base, and then maybe you can see that roughly 3 little cones fit into it, so that's why we divide by 3. So pi r squared times the height divided by 3 is the volume. So I know that the volume of the cone is 60 pi centimeters cubed. I know the pressure on the floor is 90 newtons, and I need to work out the force. So to work out the force, what I really need is the area of the face that comes into contact with the table, or in this case the floor. So that's all I really need. And actually I think I've been given some superfluous information. So this is really annoying because some people are like, oh, I've been given this information, do I need to use it? Well, I know that the radius is 3. So what's the area of the circular part that comes into contact with the base going to be? It's going to be pi times 3 squared, which is 9 pi. And if this is a non-calculator question, we can just leave things in terms of pi. So how do I work out force? Force is pressure times by area. So I know that the pressure is 90 newtons. So I'm going to do 90 times by 9 pi. Therefore, 9 times 9 is 81. Add the 0. 90 times 9 is going to be 810 pi. Newtons over, I think maybe this question is not exactly worded right, but if it's just asking for the force, then yeah, it would be 810 pi newtons. Okay, so speed, distance, time question, and these questions people always seem to get wrong because they forget that generally, unless the question is specifically talking about meters per second, whenever we're talking about minutes and hours, time, you always want to write it as a unit of an hour. Okay, so that's a really, really key thing to remember. So Anisha and Leah go on a road trip from London to Cornwall. They start their trip in London and travel an average speed of 70 miles per hour for the first 3 hours. So remember that speed is distance divided by time. They then travel a further 90 miles at an average speed of 30 miles per hour. Work out their average speed. Okay, so to work out average speed, what I need to do is work out the total distance and divide that by the total time. People always get confused with this and they just think, oh, I'll just add the 2 speeds together and divide by 2. Nope. No, we need the total distance and the total time. So let's figure out the missing pieces. For the first part, I know their speed is 70, so 70 equals distance divided by time. So how could I work out the distance? Well, the distance is going to be 210 miles, because we're talking in miles here. So their initial distance is 210 miles. Then they travel for a further 90 miles, okay, at an average speed of 30. So speed equals distance. We don't know, well, yeah, we know the distance, 90 divided by time. So I now need to work out the time. If I rearrange it, I can write 30t equals 90 over 30. I could rearrange it so that 30t equals 90 and then say that t is 90 over 30. Or you can know the trick that if you're trying to make the denominator the subject, you just switch them. So t is going to be 90 over 30, which is 9 over 3, which is 3 hours. Okay, so that is 3 hours that they travel. So this is a nice and easy non-calculator one. I didn't actually need to do any of those time things, but in the next question I have a feeling we will. So the average speed is going to be the total distance. So 210 plus 290 is 300 miles, and the total time, oh, this is a super easy question, is 3 hours plus 3 hours, which is 6. So 300 divided by 6 is going to give me 50 miles per hour. And that's how I'd do a question like this. Okay, so here I've got a slightly more challenging speed, distance, time question. So Elisa travels from Birmingham to Nottingham at an average speed of 50 miles per hour. The journey takes her 1 hour and 10 minutes. Now remember what I said, speed, when you're dealing with speed, distance and time, you always want to write it as units of an hour. Okay, so how do I turn minutes into hours? Well, there's quite a few ways I can do this. Either I can turn the whole thing into minutes. So 1 hour and 60 minutes in total is 70 minutes. And to turn that as a fraction of an hour, I do 70 over 60, which is 7 over 6. And 7 divided by 6, 6's into 7 go once, remainder 1. 6's into 10 go once, remainder 4. 6's into 40 go 6, remainder 4. 6's into 40 goes 6, remainder 4. And so you're going to find yourself with a recurring decimal. Okay, so I know, what was I trying to work out? That the time for Elisa is 1.16 recurring hours. Okay, I'm then told that Atazaz makes the same journey in 45 minutes. So once again, I need to write that as a fraction of an hour. So to turn minutes into hours, you just write it over 60 because there's 60 minutes in an hour. And that would eventually simplify to 3/4, which is 0.75. Okay, so Atazaz's time is 0.75. So work out Atazaz's average speed for the journey. So how do I work out speed? Well, speed is distance over time. So I know that the distance is going to be the same. Oh, I haven't actually worked out the distance. So I need to work out the distance that Elisa travels. So distance is speed. Her speed is 50 times by time, 1.16. Oh, this is, so in a non-calculator paper, I'm just going to reach for my calculator. You're not going to be given a recurring decimal like this. So I'm just going to work it out on the calculator because, you know, we don't need to do that. 50 times 1.1 and then 6 recurring. If you didn't know how to press the recurring button, it's that one like here that has a little thing at the top. So shift recurring gives me 175 over 3. So the total distance is 175 over 3, which is 58.3 recurring. So I know that Atazaz's average speed is going to be the distance, which is 58.3 recurring, divided by 0.75. In the non-calculator, you'll be given much nicer numbers. So 58.3 recurring divided by 0.75 gives me 77.7 recurring. So 77.7 recurring miles per hour. So that tells me that Atazaz was speeding because the national speed limit is 70 miles per hour. Oh, another quick thing. If you forget the formula for speed, distance, time, just think of the national speed limit, which is 70 miles per hour. 70 represents the speed. Miles, that is a measure of distance. Per means divide, and hour is a measure of time. So if you ever forget it, you can always think national speed limit, speed is distance over time. Okay, so here we're dealing with inverse proportion, and all inverse proportion means is that, so if you think about like builders, if you have one builder building a house, that's going to take a lot longer than if you had 20 builders. So let's say one builder, it takes them 20 days. 20 builders, it's going to take them a lot less because there's more manpower being involved, more people are helping. So as one variable increases, the other decreases, and that is the concept of inverse proportion. So Zara manages a donut factory. On a normal day, 15 donut machines take 3 hours to make 1,500 donuts. Okay, so 15 donut machines take 3 hours to make 1,500 donuts. This is an extensive question. So I know to make 1,500 donuts, 15 machines take 3 hours. So what I could do is I could figure out how long one machine would take to make 1,500 donuts. So how do I get from 15 to 1? I divide by 15, and because it's inverse proportion, I'm going to have to do the opposite to the other side because it actually means it's going to take longer. If 15 machines are busy wearing away, one machine is only going to be doing 1, 1, 1, 1. So 3 times by 15 is 45. Okay, so it would take one machine 45 hours to make this. Okay, so what I could then do, would I need to? I haven't read the rest of the question, but I know that it takes 45 hours to make 1,500 donuts. So therefore it would take 15 hours to make 500 donuts. And I could just leave it as that because I don't actually know if I need any of this. Okay, so it says 5 of the machines break down on Tuesday morning. That's a shame. How much longer will the remaining machines have to work in order to make the same amount of donuts? Okay, so I know that one machine, I'm trying to make 1,500 donuts in total. It would take one machine 45 hours. If 5 machines break down, then what I can do, let's just rub all of this. So 5 machines break down, so that means she's only left with 10 machines. Okay, so I know that it takes one machine 45 hours, 10 machines to get from 1 to 10, I'm going to times by 10. So over here, I'm going to have to divide by 10. 10 machines, it would take them 4.5 hours. Okay. Oh, this isn't actually, I thought it was going to be a really long question. So 10 machines would take 4.5 hours. How much longer will the remaining machines have to work in order to make the same amount of donuts? Well, I know in total it would take 10 machines 4.5 hours to make 1,500 donuts. So therefore, if it normally takes 3 hours, 4.5 take away 3 is 1.5. So it would take them an extra 1.5 hours to complete the same amount. Okay, so here I'm dealing with standard form conversions, and when I'm writing something in standard form, I literally want my number to convert it into a digit that's between 1 and 9.9 and times it by 10 to the power of something. So I keep all of the digits the same. I just put a decimal point after the first non-zero digit. So that would be 4.56 times by 10 to the power of, and you could, if you're really stuck, just actually work out what the powers of 10 are. So timesing it by 10 to the power of 1 would just be 45.6. Timesing it by 10 to the power of 2 would be 456, and so forth. Or the quick way, if you're feeling comfortable with standard form, is just count the amount of digits after your first digit. So 1, 2, 3, 4, 5, 6. So it would be 10 to the power of 6. When we're doing standard form and it's a decimal number, we're actually dividing by a power of 10. So the trick here is, once again, find the first digit, that's 5, the first non-zero digit, 5.78, and times it by 10 to the power of however many zeros you have before the digit starts. So that would be 1, 2, 3, 4. 10 to the power of -4, because you're dividing by that. And over here, we're doing the opposite. We're writing it as an ordinary number. So you write your first digit, and you know it's 10 to the power of 7. So you want 7 digits, 7 place value holders after the 4. So 5, 2, that's 1, 2, 3, 4, 5, 6, 7. Put your commas in, and that would be 45,200,000. And with the standard form, when we're dividing, when it's a decimal, you count how many zeros there are. So 0.1234, and then you start writing your number. Okay, and that's the quick shortcut way. If you want to know how it works, then watch a long extended video. So calculation for standard form is a little bit harder, but you do the same thing. So we're trying to work out the value of this. So I could write it as a fraction. So 4 times by 10 to the power of 5 divided by 2 times by 10 to the power of -3. And what I could do is 4 divided by 2 leaves me with 2, and then 10 to the power of 5 divided by 10 to the power of -3. When I divide decimals, when I divide powers, I'm subtracting the powers. So that would become 10 to the power of 5 minus -3, which gives me 10 to the power of 8. So I'd be left with 2 times 10 to the power of 8, and I need to work out the value of that. So I'd write 2 and then 1, 2, 3, 4, 5, 6, 7, 8 zeros after my point. So that would be 200 million. Now I'm adding and subtracting with standard form. So there's a few ways that we can do this, but generally you're just going to have to work it out and then add it. So 3.93 times 10 to the power of 3. Okay, so I'm timesing it by 1,000. I know that 3 times 1,000 is 3,000, so that one's quite simple, but you still use the formula, so 9, 3, and then a 0. And then I'm adding 3.24, so I'd write the 3, and then it's to the power of 5, so 5 digits after the 3, so 2 and the 4 are already there, so 1, 2, 3, 4, 5. So I'm essentially just adding 324,000 with 3,930. So I can just add them together. 4 plus 3 is 7. So I'm left with 327,930. And I want to give my answer in standard index form. So once again, I turn the digits into a number between 1 and 9.9. So that would be 3.2793 times by 10 to the power of, well, 1, 2, 3, 4, 5. And that's how you do your additions. You'd work them out first, add them, and then convert it back into standard form. So here we've got a little bit of problem solving. We're told that the area of the face of a cube-shaped sculpture is 25 meters squared. So I've got a cube-shaped sculpture, and I know that the area of one of the faces is 25 meters squared. And I now need to work out the volume. Okay, so if I know what the area is, in order to work out the area of a cube, I know I've got a side and then it's a cube, so each side is going to be the same. How do you work out area? It's length times width. So the area of the face is going to be s squared. So in order to work out the side, you don't divide by 4. It's a common misconception. You square root it. So I know that the area is 25. Therefore, to work out a side, I'm going to do the square root of 25, which is 5. So I know that all of my sides are going to have a length of 5 because it's a cube. All sides are equal. And I need to work out the volume. How do you work out the volume? You work out the area of the cross section and then you times it by the length. So 5 times 5 times 5 is 5 cubed, which is 125. However, you need to make sure that you're reading the question carefully. So it says the area of the face is 25 meters squared. So that's going to be 125 meters squared. Sorry, 125 meters cubed, because it's now turned into a volume. And I need to work out the volume in centimeters cubed. So either you memorize what the units for volume are, or if you get stuck in the exam, you think to yourself, okay, so I know that if it was a cube, 1 meter is equivalent to 100 centimeters. So I do 1 times 1 times 1, which is 1 meter cubed. But if the same was centimeters, I'd have to do 100 times by 100 times by 100, which is 1 million centimeters cubed. So if you panic in an exam and you've forgotten, then just work them out yourself by equating the two. You know that 1 meter is 100 centimeters. So therefore, it would be 125 million centimeters cubed. Okay, so here I'm told that the side length of a cube is increased by 25%, and I need to find the increase in the volume of the cube. So I can start by just having my generic cube. What do I do to work out the volume of a cube? I multiply length times width times by height, which would be x cubed. So that's my original cube, it's just 1x cubed. Now for my next cubed, I've multiplied each side by, or I've increased each side by 25%. So that means that each side is 1.25 times the original length. Now, if this is if this is a calculator paper, you just do 1.25 times 1.25 and so forth, but it's a non-calculator paper, so we're going to try and be smart and do as little kind of work as we need to, as in do the work, but in a smart way, shortcut way. So 1.25, the best thing to do is to just turn it into a fraction. I know that 25% is a quarter, so therefore an increase, if 100% is going to be 4 quarters, 125% would be 4 quarters plus 1 quarter, which would be 5 quarters. So I could then say that would be 5 quarters x times by 5 quarters x times by 5 quarters x, because each side is going to be 1.25 lots of x. Okay, and the reason I just did it as fractions is just a lot easier to multiply 5 by 5 by 5 than it is 1.25 by 1.25. So 5 times 5 times 5 is 125. 4 times 4 times 4 is 64. So that would give me 124, 5 over 64 x cubed. Now, I'm going to need to write that as a decimal in order to work out the increase. So 125 divided by 64. I can just do the the halving because it's a fraction. So half of 125, half of 125 is going to be 62.5. Can halve it again. 62.5 divided by 2 would be 31.25 over 16. Half it again, just because if you half it and then the denominator is a single digit, it makes it so much easier to divide. So half of 30 is 15. Half of 1.25 is going to be 0.625. Is that right? It's been a long day. Yeah. So 15.625. And then we can just use our bus stop method. So 15.625 divided by 8. 8s into 15 go once, remainder 7. 8s into 76 go 9, remainder 4. 8s into 42 go 5, remainder 2. 8s into 25 go 3, remainder 1. 8s into 10 go 1, remainder 2. 8s into 20 go 2, remainder 4. And 8s into 40 go 5. So your total increase, if the original volume of your original cube was just 1, your new cube is going to be 1.953125. So the percentage increase is 95.3125%. So it's almost doubled. But yeah, a little bit tricky, especially because you're dealing with, if it's a non-calculator paper. If it was calculator, lovely. You just do 1.25 times 1.25 times 1.25. Okay, so a similar kind of question here. I'm told that here are 3 spheres and the volume of sphere B is 40% more than the volume of sphere A. So if I just say that sphere A has a volume of 1x, sphere B is going to be 1.4x, and the volume of sphere C is going to be 20% more than the volume of sphere B. So it's going to be 1.4 times by 1.2x. Now, I could do this in decimals, or you can, the answer is asking it for a fraction. So let's turn it into a fraction. I know that 40% is 4/10, which is 2/5. So if this is a whole, that would be 5/5. So therefore this 5/5 plus 2/5 is going to be 7/5 x. And if I then multiply 7/5 by a 20% increase, I know that 20% is 2/10, which is 1/5. So I'd be multiplying it by 6/5 because I'm including the original percentage. So the original is 5/5, 20% more is going to be 6/5. So 7 times 6 is 42 and 5 times 5 is 25. So I know that this sphere, sphere C, is 42/25 of the volume of sphere A. And I need to find the volume of sphere A as a fraction of the volume of sphere C. So I'm going to say 1 over 42 over 25, but we don't like doing triple tiered fractions. So when you're dividing a fraction, what do? You keep the first part as it is, you change the sign and you flip it so that it's a reciprocal and you multiply. So that would be 1 times 25 over 42. So we just say it's 25. Okay, so here we've got a compound interest question. I'm told that Leticia invests £20,000 in a savings account, offering a compound interest rate of 2% per annum for 3 years. Now, the difference between compound interest and simple interest is that compound interest is super fun because at the end of the year, you make interest on all of the money that is in your account, not just the initial investment. So each year you're actually making more and more and more money, and by the end, if you've got a lot of money and you've been making loads of interest, it just compounds into this snowball effect of craziness. So compound interest can work hugely in your benefit if you have a long time horizon. Now, this is a non-calculator question. If this was a non-calculator question, there's a few ways we can attack it. So when we deal with compound interest, the formula is the original amount times by the multiplier to the power of however many years that we invest for. So the original amount is 20,000. The multiplier I work out by doing 100% plus the interest rate. And I do that because you can't just discount your £20,000 that you have already. So you have 100% and then you're adding on 2% to it. So that would become 102%. And what's 102% actually mean? It means 102 over 100 because percentages mean divided by 100. So if we divide that, that would be 1.02. So your multiplier is 1.02 and the number of years they've told us is 3. So if it's a calculator paper, you could just multiply it like that, but it's non-calculator paper. If you are really good at multiplying, you could just do 1.02 cubed and then multiply. If not, then the safest thing might be to just work it out year by year. So if we did £20,000 times by 1.02, that would tell us how much money she has at the end of year 1. So I'm trying to work out 2%. 2% of 20,000 is 200. So therefore 1% of 20,000 is 200. So therefore 2% is going to be 400. So I'd have £20,400 at the end of year 1. I do the same for year 2, except I now have a new amount. So I'm going to do 24,000 times by 1.02. And I'm saying times by 1.02, all that means is adding you can also do it by just finding 2% and adding it on. And if you're doing it the manual way, that's the easiest way. So 1% of 20,400 is going to be £204. So therefore 2% is going to be £408. So that would be 20,808 at the end of year 1. And then I do the same thing for the third year. So I'd do 20,808 times by 1.02. And remember, I'm timing by 1.02, but because I'm doing it manually, I can just work out to 2% and add it on. So 1% of this would be £208.08. So therefore 2% is going to be £416.16. So if I add that on, I'm going to get £21,224.16 at the end of year 3. So now the question is asking me to work out how much interest she earns. So I'm just going to subtract the original investment amount, which is 20,000. So the interest earned is £1,224.16. Okay, so here I've got compound depreciation. Now I can do this in the same way I did the previous question where I worked out 10% and subtracted it each year, but because this is a slightly easier number, I can do it the decimal way. So remember, the formula is the original value times by your multiplier to the power of the number of years. So what's my original amount? It's 5,000. What's my multiplier going to be? Well, this is a depreciation. So depreciate means goes down in value. So if my original was 100% and I'm taking away 10%, then my multiplier is going to be 90%, which as a decimal is 0.9. So I'd do times 0.9 cubed. So you can do it the other way, but I'm just going to show you another way just so that you have all options. So 0.9 cubed, well, what's 9 cubed? 9 times 9 is 81, and then 81 times by 9. 9 times 1 is 9. 9 times 8 is 72. so that's 729. So I'm going to do 5,000 times by, and remember when you're multiplying decimals, you turn them into whole numbers, but then however many digits, so if I did 0.9 times 0.9 times 0.9, however many digits are after my decimal point, that's how many I need after my decimal point. So that's going to be times by 0.729. That's going to give me my final answer. So now I once again I can do whatever multiplication method I like. I'm just going to use the lattice method. So 729, and actually there's a few ways that we could do this. So I'm just going to do it times by 5 because there's no point in doing 5,000. So split it into 2. 9 times 5 is 40. 2 times 5 is 10. 7 times 5 is 35. So I know that that's going to be 0. 4 plus 0 is 4. 1 plus 5 is 6. So I know that 729 times by 5 is 3,640. So what have I actually done? Well, I've turned everything into a whole number. So to turn it into 0.729 times by 5, I need 3 digits after my decimal point. So that would be 3.64. And now to times it by, because it's timesing it by 5,000, I need to times it by 1,000 to get it back. So that would be 3,640. That doesn't make any sense. Don't worry. I'm just doing a strange, weird way. You can just multiply the normal way. So what is the value of the car after 3 years? It's 3,640. And again, if it was a calculator paper, you'd literally just type in 5,000 times by 0.9 cubed, and then you get your final answer. I also just realized I said that 9 times 5 is 40. When it's not, it's 45. So this should be 5. That's embarrassing. But hey, we all make mistakes. Okay, so this is a bit of a complicated looking question, but all I need to do is use my knowledge of fractions and do some working. So Ben and Tate play a game. Yellow shapes and red counters are used in the game. Some of the counters are triangle, all the other counters are circles. The ratio of the number of yellow shapes to the number of red shapes, I'm assuming shapes and counters are interchangeable. So yellow shapes to red shapes is 4 to 6. So therefore 4/10 of the shapes are yellow and 6/10 are red shapes. I'm then told, so remember to turn a ratio into a fraction, to say what are all the parts out of. They're out of 10, so that would be 4/10 and 6/10, and they all add to make a whole. The ratio of the number of yellow triangles to the number of yellow circles is 3 to 6. So out of the yellow shapes, 3/9 are triangles and 6/9 are circles. And for the red shapes, I know that the number of red triangles is 3/7 and red circles is 4/7. All I've done is I've turned these ratios into fractions. I need to work out what fraction of all the shapes are triangles. Okay, so I know that 3/9 of 4/10 are triangles. Remember in maths, you might not know, but of means a multiplication. So 3/9 of 4/10 are triangles, and also 3/7 of 6/10 are triangles. So 3 times 4 is 12, 9 times 10 is 90, 3 times 6 is 18, 7 times 10 is 70. So I've got two fractions here, and I need to add them together. So I've got 12 over 90 plus 18 over 70. The lowest common multiple of 90 and 70. What you can do if you don't like doing this is you can simplify your fractions first. So 12 over 90 is going to be 6 over 45, which if I divide by 3 is going to be 2 over 15. Do the same over here. 18 over 70, if I half it, is going to be 9 over 35. If I divide it by 3, it's going to be, 3 doesn't go into it. So I'm going to have to leave it as that. So I need to work out 2/15 plus 9 over 35, which is a little bit simpler than working out 90, the lowest common multiple of 90 and 70. So the lowest common multiple of 35 and 15, this is a non-calculator paper, this is a slightly long question, but we've got 35, 70, 105, 140, 175. Then we've got 15, 30, 45, 60, 75, 90, and then 105. So the lowest common multiple of 15 and 35 is 105. So I'm going to write both fractions over 105. What have I times 15 by to get to 105? 1, 2, 3, 4, 5, 6, 7. So I'm going to have to times the numerator by 7 as well. And then what have I multiplied 35 by to get to 105? 1, 2, 3. So I have to times 9 by 3 as well, which is 27. Add them together. 14 plus 27 is 37 plus 4, which is 41 over 105. So it looks like quite a complicated question, but all you're doing is working out a fraction of a fraction. And if you set it up like that, and remember that of means multiply, it hopefully makes it a little bit easier. So thank you very much for watching. Hopefully you found something helpful in there. And if you like this video, then just press a like or subscribe to show your support.